Hi, my name is Joe Chacon. I'm an electrical engineer with Padge LLC. This is the final video in our series on harmonics. Today we're talking money, the real world cost of harmonics, and the return on investment of mitigation called ROI. Let's start with what happens if we ignore harmonics. We might not notice it at first, but over time, transformers will run hotter and die earlier. A unit designed for 30 years may burn out in 10. That's a $10,000 to $200,000 hit, depending on the size and class of the transformer. Conductors will waste more energy, leading to higher utility bills. Drives and motors can fail, especially with the high THDI and rapid voltage fluctuations. Sensitive electronics, power supplies, VFDs, PLCs, chargers, medical equipment, they all start to fail due to dielectric stress and voltage distortion. We may end up with mystery downtime, high replacement costs, and a trail Band-Aid fixes that never get to the root cause. Most utilities don't fine us yet for IEEE 519 non-compliance, but it's coming. And if we're already doing grid tie, solar, batteries, or large loads, our interconnection agreement may already require compliance. But what's far more common is this: power factor penalties, which can be exacerbated by harmonics. If our site's power factor drops below 0.9 or 0.95, our utility may apply penalty charges, demand ratchet increases, or reclassification into a higher billing tier. Let's look at an example. A facility with 500 kilowatt load operating at 0.82 power factors billed on kVA demand. That means we're charged for 610 kVA instead of 500 kilowatts. If our utility's demand charge is $12 per kVA per month, that's 110 kVA times 12 times 12 months, which is $15,840 per year in excessive cost. Correcting our power factor to 0.95 will drop the demand to 526 kVA. That alone could save us $10,000 to $15,000 per year. Active harmonic filters can correct both harmonics and power factor. With one smart piece of equipment, we can clean up THDI, THDV, stay within our IEEE 519 limits, improve our power factor, and avoid utility penalties. Let's look at a mitigation investment example, that being our active harmonic filter. It might cost us $15,000 to $25,000 to install. Passive filters, like individually placed line reactors and filters, may lower the cost, but they may not cover power factor or dynamic loads, and they may not be feasible in our facility. So a realistic savings potential for this example is about $2,000 to $15,000 for utility penalties avoided, and energy savings, efficiency savings, that is, of $1,000 to $5,000 per year. One could easily save $5,000 to $50,000 over a few years in electronics and VFD drive failure prevention. Transformer replacement avoidance can be up to $100,000 or even $200,000 depending upon the price of the transformer. Downtime prevention is worth anywhere between, let's say, $1,000 to $100,000 plus, depending upon what our facility does. So let's say that we actually install this filter for $18,000. We avoid $3,500 per year in penalties. We save $2,000 a year in energy. We prevent a $25,000 transformer failure every 10 years. We extend the life of a dozen $800 power supplies and a few $4,000 drives. The ROI payback on this period, for this period that is, could easily be just 20 months. Harmonics mitigation isn't just an engineering topic. It's a business decision. We'll improve system reliability, reduce energy cost, extend equipment life, and avoid regulatory headaches, all while boosting safety and compliance with NFPA 70E and IEEE 519. I hope it is a bit clearer as to how mitigating harmonics is as much a business decision as a technical issue. I hope this knowledge can help you become the harmonics guru for business applications in your company. Please look us up at padge.org. That's PADGE.org. If you need anything on this topic or others, we will see you in the next series. Thank you.